will be presenting Specviz, which is the first of 3 configurations of the JDAT project that Kemi mentioned earlier. So to get to my notebook, I'm going to click on the folder tab here on the left and go to Specviz Webinar Live. As Kemi mentioned, if you want to follow along with the solutions notebook that already has the code and the cells filled in, that's probably the easiest way to follow along. And as she mentioned, you'll still need to actually execute the cells to get the code to run. So I will go into a little more detail for that in a moment. A quick introduction to Specviz. As the name might suggest, this is intended for viewing and analyzing 1D spectra. And again, as Kemi mentioned, this is part of the JDAT project. So if you were to go try and get Specviz on your own, I'll just make a quick note here. You would not do something like pip install Specviz. That would get an old version of the tool that's not supported anymore. Now Specviz lives in JDAT, so you would pip install JDAT if you wanted to go get this yourself on a local machine. I also included in this notebook a link to the documentation page. So here, if I go to the top level, you can see this is the JDAT documentation, and then you can navigate into Specviz and see things like, how do I define spectral regions? We have documentation and screenshots that we hope lays it out pretty clearly. And as mentioned before, this is all open source and on GitHub, so if you find something isn't clear and want to complain to us, you can always go make an issue in GitHub and say, hey, this part of the documentation needs a little work or something like that. So getting into the actual usage of Specviz. As always, in Python, I need to import some things. So to get Specviz, what I'm doing is from JDAT, import the Specviz class. You'll see I also import some things from AstroPy. So after importing that, what I need to do is I need to instantiate an instance of the Specviz class. So I will just call that all lowercase Specviz. And then to actually bring up the app in the notebook, I just type specviz.app. And to run the cell, hit Shift-Enter. And you can see this brings up an interactive application inside of the Jupyter Notebook. One thing that might be useful for people, if you want to be able to see the app and not have to scroll back and forth to look at the cells that come later on, you can right-click on this code cell, and you could create a new view for output, and that should open a separate window that has the application in it. Totally optional, but some people have found it useful in the past. So just a couple quick notes about the structure of this application. I'm going to call this blue bar going across the top the app level toolbar or the top level toolbar. On the right of the toolbar there, you can see there's this Lego block icon. If you open that up, it pulls up a tray with what I'm going to refer to as data analysis plugins. So these are built-in functionality to do some things with Spectra. To collapse this, you would just click on the Lego icon again, and that would make that tray collapse. And then below that, we have what I'm going to refer to as a viewer. Currently, it just has X and Y axes because we haven't loaded any data. That viewer nomenclature is not too important here because we only have one viewer in Specviz, but in Mosviz and Cubeviz, there will be multiple viewers. There will be image viewers. Each of them also have a spectrum viewer, as we have here, but just take note of that. And then at the top left of our viewer, the viewer itself has an expandable toolbar, which you get to by clicking this hammer and screwdriver icon. So we'll come back to that. Now let's get some actual data in here. First, we're going to download this file from Box. This is a spectrum extracted from a simulated observation of a galaxy through the NearSpec IFU. So this is simulated JWST data. And once I've downloaded that, all I need to do to get it into the app is do specviz.load spectrum, and then give it the file name of that downloaded file. And I can also give this a data label. I'll call it just demo. So that way, I'll be able to see in a moment, this data will have a nice label attached to it as opposed to some long file string or something. I will also note on the back end, this is mostly backed by AstroPy. code on the back end, as well as specifically Specutils, which Eric will be talking about later. So when I called load spectrum here, this is calling a Specutils file reader in the background that has a bunch of preset data loaders included in it. So this automatically identifies that this is a JWeb file and knows how to open that without the user having to do anything terribly complicated. If we scroll back up here, we can see our spectrum has been loaded. It's populated the axes labels with wavelength and flux density in the units from the file automatically, so that's great. And if we open our viewer toolbar here again by clicking this hammer screwdriver icon, we can see some initial things we can do with this. So first of all, you can pan and zoom around. So the crossed arrows here are kind of a free form pan and zoom. I'm interactively zooming here with the scroll wheel on my mouse. If you're working with a laptop touchpad, it's maybe a sort of pinch zoom functionality. And I'll talk in a moment about how you can also zoom from the notebook if you don't have either of those options available to you. We can also, these next two arrows are for panning and zooming one axis only. So if I, for example, wanted to lock the y-axis and only pan and zoom on the x-axis, I could do that here. So if you do get lost, if you've lost your spectrum by panning and zooming away from it, you can run this cell and zoom and get back to your spectrum. And that is also what I was planning to mention, that if your scroll wheel on your mouse or you don't have a scroll wheel, this is the other way you can zoom. Other things that are available on this viewer level toolbar, we can click this floppy disk button to save out the current plot as a PNG or an SVG. And then this gear icon, if we click that, there's a data dropdown. Here we can see it's labeled with the demo label that I gave it. So if I had multiple data sets loaded, I could choose what is displayed on the app. And actually, this is a way that you can also go back to auto scaling currently, is if you just uncheck and recheck the data. Other things I can do here, let me zoom back in just a little bit so it's perhaps more apparent. Other things you can do here in the layer tab, you can do things like increase the width of your line. You can make your lines different colors. For example, if you had multiple spectra loaded and you wanted to make them a little more distinguishable. And then the viewer tab's not really relevant for us here, so I'm just going to skip over it. Now, I rather conspicuously skipped over this icon, so I will now explain what that is good for. So oftentimes when we're analyzing spectra, what we're really interested in is looking at particular features of our spectra, not just running some algorithm on the entire spectrum at the same time. So in order to tell this application that we're interested in particular segments of the spectrum, we can create what I'm going to call subsets. So if we go to the top level toolbar here, currently there's this gray button that says no selection, create new. This is indicating that we currently have not created any subsets. And the button next to it is going to give us options on what happens when we use the tool to define a subset. So the default is replaced, that's fine. We don't have anything defined yet. I'll just leave it as the default. And then to actually create a new subset, since I have no selection create new displayed, I'm going to go into the viewer toolbar and select the X-range selector tool. So once I click that, then I can go to my spectrum and I can click and drag a region of the spectrum to define a region. Let me go into the layer tab here and make that a little bit thicker so it's easier to see. So now I hope you can all see that a section of the spectrum here has been highlighted in red. And if I go back up to the toolbar, you can see that now instead of saying create new, it says subset 1, and there's a red triangle there showing that subset 1 is denoted by this red highlight. What are these subsets good for? A quick example, if I were to say go into the model fitting plugin and go to this data dropdown to select which data I want to fit, I see here I could either select demo for the whole data set, which is super useful usually, or I could select subset 1. So I could say I just want to fit this subset of the data to investigate this emission feature. I'm not going to go through the full demo of the model fitting plugin now because Zui is going to demonstrate that in the Mosviz presentation. These tools are all very linked, so most of what you can do here, you can also do in the other configurations in Mosviz and Cubeviz. I will just note real quick, if I wanted to make another selection, I could go back and click on this button here and reselect the No Selection Create New option, so that if I chose the region selector again, I could, for example, select this line. And now let me make it again a little wider so you can see. Now that selection has been highlighted in green. So you can see that subset 2 now is denoted by the green highlights. Subset 1 is still denoted by the red highlights. So you can do multiple selections. You can remove sections from your existing subsets. You can add more to them. All sorts of great things like that. I said I'm not going to demonstrate the model fitting plugin now. However, if you scroll down in the notebook, there's text detailing all the things I'm showing here, and there's also some text laying out how to do things that I don't have time to demonstrate right now. So there is actually a section on how to create and fit models. And the other thing I will note right now is that all of our notebooks are also going to include some exercises. So things that we might not get to or extensions of things that we're demonstrating, you could go on your own and do the exercises. And if I go over to the solutions notebook real quick, you can see that after the exercises, I have a solution section here that attempts to lay out in some reasonable amount of detail how you might go about doing the solutions. The last thing that I wanted to show in Specviz, that's kind of more Specviz specific, is displaying spectral lines. So often we know we're interested in, say, this is a galaxy, I'm looking at this. I'm not going to claim that I would know this just from looking at this, but from talking to our scientists, I know that there's an oxygen feature in this spectrum, there's hydrogen alpha. So if I have some spectral lines that I know I'm interested in, I can add these to the plot and plot them on top of my spectrum. There's a few ways to do this. The first way is that we include in this package some lists of lines that people are commonly interested in. Some of these are fairly specific to what you might see in a James Webb spectrum. Some of them are sort of more general. I'm going to select the common nebular line list and load that just so we can see what that looks like. So we can see this told us, hey, we loaded the lines from a preset list. You can show them from the dropdown in the line list plugin. So when I loaded this, this under loaded lines populated the common nebular line list. And if we open that, we can see there are a ton of lines in here. I'm going to select O3, 5,000 angstroms, and hydrogen alpha. If I can manage to see that, there we go. So I've clicked on those, and you can see that column is denoting whether that line is visible. We don't load them all when you load the list because there are a ton of them. And it's not that useful to see a bajillion lines at the same time, and it slows down the app a little bit if you load 100 or something lines. So we notice now I made those visible, but they're not actually on my spectrum. And if I look at my x-axis, I say, oh, right, I'm not actually in a wavelength range where those lines are. So the spectrum is redshifted. And what I can do is I can go to this redshift slider at the top of the app, and I can move this slider around to change the redshift that's applied to any lines that I've added. By default, you can see this only goes to 0.1, and my lines haven't showed up. So I'm just going to input here, let's just say 1.7. And now my redshift slider has scaled, and I can see my lines are indeed now visible, so I'm kind of in the right area. And if I move the slider around, you can see the lines move. And if I go there, these are matching up pretty well. I can see it looks like this is probably a galaxy at 1.5 redshift. And since I know this is simulated, I suspect that somebody simulated this at exactly a redshift of 1.5. As a quick note, the other ways you can add lines, if you just know you have, say 2 lines you're interested in, you can go into the custom list and you can just add lines. So I could just say, oh, there's a line at 4,000 angstrom and add that in the custom list. And you can also define a line list in the notebook cells. The solutions notebook has code filled in to do this. So you could create, for example, an AstroPy table with some lines in it and then load that into the application and have those lines show up.